Okay, so we've been talking about the dosages and using that dosage calculation formula. Before we go any further, I want to mention that concentration again. A lot of bottles will actually come as a powdered medication in a vial, in a sterile vial, and you have to constitute it. So constituting a solution. If you're looking at that label, we've said the label said 25 milligrams in 2 milliliters or whatever. When you're interpreting that label, you might see a label that says 600 milligrams of whatever medication we're using. We'll put in just the word serum for generic medication. So 600 milligrams of serum, then constitute to 120 milligrams per milliliter with 4.5 milliliters of, and usually on the label, instead of using NS, they'll use the term sterile water. For injection or whatever. If you look at this, the math doesn't quite work out. They're saying that this contains 600 milligrams, and we're going to constitute it with 4.5 milliliters of sterile water. That's 600 milligrams. It appears to be in 4.5 milliliters. But remember, this would be considered a weight in volume solution. And in a weight in volume solution, the medication does take up some of the volume. So the 12 milligrams per milliliter here, 120 milligrams per milliliter, we thought of as 120 milligrams per 1 milliliter, would seem to indicate that 600 milligrams, if you were to cross multiply and divide on this, 1 times 600 divided by 120, should take up 5 milliliters. And it does. It's just the label is telling you if this is a sealed vial, you can't dump the medication into a beaker and then add sterile water until you hit that 5 milliliter level. So they're telling you on the label it will take 5 milliliters of sterile water to get this to a total volume of 5 milliliters. So when you have a label like this, and this is pretty common to have a vial with that dry powdered medication in it, and you just have to add the water and shake it to dissolve it, to constitute that solution. When you have a label like this, don't try to do the totals. Trust their label that says constitute to 120 milligrams per milliliter. That is the number that you would be using in your dosage calculations. Okay then, so for our next process of calculating these dosages, we're going to look at proportions. Now, as I said, I'm going through these in the order of my least favorite to my most favorite method of doing them. When I do these, I will almost always do the third method. There are a couple of examples where the proportion is easier. In the proportion, we start with the label, and we use the label to compare the doctor's orders and what's going to be administered. Now let's take a look at how this works. In fact, let's step back for a second, and we're going to look at measurement conversions here. If we had a measurement conversion that said see this right. So it says 1 fluid ounce contains 30 milliliters. And I want to know 2.5 fluid ounces contains how many milliliters? I would start with my conversion factor, my equivalency. The equivalency is kind of like the label. It's telling us what the relationship is between those two values. I would use my 1 fluid ounce here equals 30 milliliters to make a ratio, or a rate actually. And on the other side, I would use the number that I have known. Now the known value is kind of like the doctor's orders. That is the same unit as the fluid ounces, so 2.5 goes on top. And the value I'm trying to find, which would be like the amount to administer. So that's milliliters, so that's going to go on bottom. And then we'll find that by cross multiplying and dividing. 30 times 2.5 divided by 1 is going to be 75 milliliters. So 2.5 fluid ounces contains 75 milliliters. So if we have a doctor that orders, well, let's start out with let's say 700 milligrams of medication. And our label says 200 milligram tablets. We start out with the label. You can think of the label as being the on-hand dose and the vehicle. Because that label is just a ratio. 200 milligram tablets, you think of it as 200 milligrams per 1 tablet. Previous units, when we discussed proportions and ratios and rates, we talked about, if you have 29 miles per gallon, that you have to think of that as 29 miles over 1 gallon. Same type of thing here. 200 milligram tablets is 200 milligrams per 1 tablet. Now on the other side, we have the doctor's orders, 700 milligrams. That is the same units as the 200 milligrams. So that has to go on top. We can cross multiply and divide. 1 tablet times 700 milligrams would be 700. It's milligrams times tablets. Then we're going to divide by the 200 milligrams. Well, the milligrams would divide out, so our units would be tablets. 700 divided by 200 is 3.5. So 3.5 or 3.5 tablets is what you would administer to that patient. If a doctor orders 180 milligrams of medication, and our label says 5 milligrams per liter, or per milliliter. So again, the label is telling us 5 milligrams per 1 milliliter. So that's that ratio. Constructing this ratio from the label, by the way, that equivalency, is vital for our dimensional analysis as well. So anyway, on the other side, the 180 milligrams goes on top. We are looking for what's down here. So 1 milliliter times 180 milligrams divided by 5 milligrams is 36 milliliters. So you would administer 36 milliliters to that patient. The proportion method has the same weaknesses, or some of the same weaknesses, as the dosage calculation formula. The biggest one is it's only good for one step. If you have multiple steps, you have to repeat the whole process over and over again. Let me show you what I mean. Similar to the example we did for the formula. So let's say our doctor orders $400,000 units to be administered to the patient. And on the label, you see that there are a million units per gram. And $25 milligrams in 6 milliliters. Now the doctor's orders are 400,000 units. So that's what we have to start with. That's going to be on our right side. So we have to start out with an equivalency off the label that contains units. So off our label, I'm going to use the 1 million units per 1 gram. On the other side over here, then I have the doctor's orders of 400,000 units. Now this is going to be grams down here. If I cross multiply and divide, 1 gram times 400,000 units divided by a million gives me 0.4 grams. Now just like before, I could have had this as 1,000 milligrams instead of 1 gram. That would have made this come out to 400 milligrams. So I could have changed that before. Or I could get the 4 grams and do the conversion to turn the 4 grams into the 400 milligrams. But now from that 400 milligrams, I still have to go another step to get it into milliliters. So the label is telling me there are 25 milligrams in 6 milliliters. So on the other side, I have the 400 milligrams is the doctor's orders converted to milligrams. And now I'll find what I administer to the patient in milliliters. So 6 times 400 divided by 25 is what, 96, I believe? So 96 milliliters would be administered. So you can see if there's more than one level of conversion, that proportion can get kind of complex. Let's look at dimensional analysis. I've mentioned a couple of times already, dimensional analysis is my favorite method for doing dosage calculations. And the reason for that is there's really not any dosage problem out there that you can't use dimensional analysis on. All of them can be solved with dimensional analysis. Now, typically in practice, if I'm working on calculations like this, I actually do use a mixture of dimensional analysis and the proportion method, because there are some spots where the proportion method is simpler. That'll actually probably either the end of this hour or the beginning of our next class. We'll look at dosages based on weight and dosages based on body surface area. And when you're working with those, it often is easier to use a proportion in the first step of that calculation. Dimensional analysis is just that measurement conversion. When we had, well, let's say we have that 1 fluid ounce equals 30 milliliters again. And I wanted to know 2.5 fluid ounces equals how many milliliters? Well, we start out with the known value. We're going to multiply by an equivalency. That equivalency is often a conversion factor. That's going to give us our answer. So here we have a known value of 2.5 fluid ounces. That would be kind of like the doctor's orders. We make it a fraction by putting it over 1. And now we are going to multiply by an equivalency. Now in the equivalency here, in this conversion factor, remember we need the units here to cancel out. So that tells me that we have to have fluid ounces on the bottom of this conversion factor. So that means the milliliters are going to go on top because our conversion factor here, or our equivalency, is 1 fluid ounce equals 30 milliliters. So I fill those numbers in. I always put in the units first with no numbers. And then I go back and fill in, okay, 1 fluid ounce is 30 milliliters. Once I've got the units in there, it's easy to go back to the equivalency and fill in the numbers. So now the fluid ounces will cancel out. I have 2.5 times 30 milliliters, which is 75 milliliters. And I have 1 times 1 is 1. Come on in quick, I can sign for you quick. Okay, so let's look at this as with dosages in here. So let's say our doctor's order is for 400 milligrams of a medication. Our label is 150 milligram tablets. Let's put these down as scored tablets. Actually, I said scared, but scored. So anyway, for our dimensional analysis, we start with the known value, and that will be the doctor's orders. So we're going to start out with 400 milligrams. We always make that a fraction, so we're going to put it over 1. Next, we're going to use our equivalency. Now the equivalency here comes from the label. That is 150 milligram tablets. So we know 150 milligrams equals 1 tablet. Now in this conversion factor here, there's milligrams on top here, so we have to have milligrams on bottom here so that they'll cancel out. So milligrams are related to tablets. And we look at the equivalency, it says 150 milligrams. We put 150 with the milligrams equals 1 tablet. So we put 1 with the tablets. The milligrams cancel. 400 times 1 tablet is 400 tablets. 1 times 150 is 150. And we divide that out. 400 divided by 150 is 2.67 tablets. Now the reason I put scored in here is it implies then that this has to be to the nearest half a tablet. So if we're looking at this to the nearest half of a tablet, This would be 2.00. This would be 2.50, 2.5. 3.00 would be 3. The midpoint here would be what? Between 2.5 and 3. 2.75. So the 2.67 is smaller than that. So we would round that down to 2.5 or 2.5 tablets. So if we were asked to do this to the nearest half of a tablet, this would be listed as 2.5 tablets. Let's say the doctor's order is for 80 milligrams of medication. Our label says 20 milligrams per milliliter. Again, this label of 20 milligrams per milliliter means 20 milligrams is equal to 1 milliliter. It's our equivalency. So we start out with the orders, which is 80 milligrams. Make it a fraction by putting it over 1. The label is always going to be our equivalency or our conversion factor. We're getting rid of milligrams, so milligrams have to go on bottom. The equivalency goes milligrams to milliliters. And it is 20 milligrams, so I'll put 20 with the milligrams, equals 1 milliliter. So I put 1 with the milliliters. So the milligrams cancel out. 80 times 1 milliliter is 80 milliliters. 1 times 20 is 20. 80 divided by 20 is 4 milliliters. Now, I get people that ask, usually, well, could I have taken the 80 and the 20 here and cross-canceled? I certainly could have. Both of those divided by 20 would have given me 4 over 1. You definitely can cross-cancel here. And there will be some problems where you have to cross-cancel, because we will run into some where there's too many zeros on them, and your calculator might not be able to handle that many zeros. Now we've been doing those 2-level problems. Let's take a look at one of those here quick. So let's say the doctor orders 750,000 units of a medication to be administered. The label, 500,000 units in 1 gram, and 120 milligrams in 1 milliliter, or per milliliter if you wanted to list it that way. As we saw with the proportion method that we just did earlier, one of the weaknesses was you had to repeat it over and over again if there were multiple steps. The other weakness that I didn't mention is that you have to figure out which, since you're starting with the equivalency or the conversion factor, whatever, you have to figure out which portion of the label you would use first. We would look and say the doctor ordered units, so we have to use a portion of the label that involves units. One of the strengths of dimensional analysis is the starting point is predetermined. Your starting point is always the doctor's orders. You don't have to try to figure out which piece of the label you're going to use first. The doctor ordered 750,000 units. That is what we start with. Our conversion factor then, we're getting rid of units, so I go on bottom, and we've got an equivalency between units and grams. 500,000 units is 1 gram. Now in our next step, we need milligrams. Since we are in dimensional analysis here, we can do this right in the dimensional analysis. I Our conversion factor to convert the grams into milligrams, we put 1 gram on bottom and 1,000 milligrams on top. So what we've done so far, we've gotten rid of units. At this point, it would have been in grams. Cancel out the grams. At this point, now we're in milligrams. And now we can use our next equivalency, milligrams. These are the milligrams to milliliters. It's 120 milligrams in 1 milliliter. So now the milligrams have canceled out. So now here's what I was mentioning before. If you were going to punch this in your calculator and just multiply straight across here, 750,000 times 1 times 1,000 times 1 milliliter, depending on your calculator, some of your calculators might not display that many digits. So here's a case where cross-canceling with the numbers might be important. And I would probably do this. I would cancel out 3 zeros here and 3 zeros here. That's just dividing each of them by 1,000. And from there it'll work out. So now on top, we have 750 times 1 times 1,000 times 1 milliliter. It's 750,000 milliliters. On bottom, we have 1 times 500 times 1 times 120. So 500 times 120. I'm tired, so we're going to let the calculator do the work. 60,000. And so now we have to divide the 750,000 by the 60,000. And we get 12.5. That's 12.5 milliliters. So we would administer to that patient 12.5 milliliters of medication. Now, personally, if I would have been doing this calculation, I probably would have kept canceling zeros. I said, hey, there's 2 more here, so I'll take out 2 more. There's 1 here, I'll take out another one. So I would have ended up with 750 over 60 to get a few more zeros. Whatever level of canceling you're comfortable with, feel free to do it. I just cancel out the minimum number of zeros to make this so the numbers are small enough that they don't exceed the limit of your calculator for digits. Because it gets really confusing if your calculator starts kicking into scientific notation. Let's do another example, one of these more complex examples with the dimensional analysis. So let's say the doctor orders $400,000 units to be administered to the patient. Our label, 100,000 units in 1 gram and 250 milligrams in 40 milliliters. Where do we start? The units, the 400,000 units, the doctor's orders. And of course, what do we have to do with that before we do anything else? Put it over 1 to make it a fraction. I'm proud of myself. I'm going to slide that over just a little bit. What's next? Cancel out units. So units will go on bottom. What's going to go on top? What's the label that's going to be on top?
1 gram.
1 gram. So 1 gram and 100,000 units. So the units will cancel. And I'd just go ahead and cancel the zeros here. There's 5 zeros here, 5 zeros here. Just so I'll make them go away. So right now the units that I'm in is grams. So I'm going to have to get rid of grams. What do I want to convert grams into?
Milliliters.
Milligrams we have to do first, yes. So 1 gram is 1,000 milligrams. So the grams are gone. What's next? Cancel the milligrams. So they're on top, so we're going to put milligrams on bottom. On top, we're going to put milliliters. And of course, it's 250 milligrams, so that goes to the milligrams, in 40 milliliters. So the milligrams are gone. Now, if this were me doing this, I'd probably cross off a 0 here and here as well, just to make it as easy as possible on me. So now I have 4 times 1 times 1,000 times 4 milliliters, which is 16,000 milliliters. On bottom, I have 1 times 1 times 1 times 25. So 16,000 divided by 25. 640, and that unit is milliliters. So we would administer 640 milliliters to the patient. Now, the reason I said this dimensional analysis is really powerful is because it's used for a lot of our other calculations as well. It can be used for converting flow rates. If we have a flow rate that is listed as, what do I want to put in here? Let's do 240 milliliters per hour. I want to convert that into milliliters per minute. This is just a dimensional analysis problem. 240 milliliters per hour is 240 milliliters over 1 hour. Now this time I don't want to change the milliliters. They're going to stay the same. I want to change the hours into minutes. So in my equivalency, it's the hours I want to cancel out. Since they're on bottom, I'm going to put them on top. So I'm changing it to minutes, so minutes have to go on bottom. 1 hour equals 60 minutes. So the hours cancel out. I have 240 milliliters times 1 is 240 milliliters. On bottom, 1 times 60 minutes is 60 minutes. I divide that out. Oops, I put milliliters on that. It should be minutes. Now I divide that out. 240 divided by 60 is 4 milliliters. Divided by minutes is milliliters per minute. So that goes from 240 milliliters per hour to 4 milliliters per minute. So since I brought up IVs, let's talk a little bit about IV flow rates. So an IV flow rate quite often can be given as let's say we're given 1,200 milliliters over 8 hours. There are a lot of conversions that we can do off of this. So we take that doctor's order of 1,200 milliliters over 8 hours. The simplest one we can do is just find milliliters per hour. How many milliliters per 1 hour? And to do that, we create our rate, 1,200 milliliters over 8 hours. And if you recall back to when we did our ratio and rates and proportions, rates are always expressed as unit rates. So all we are doing here is converting this into a unit rate. In a unit rate, we just divide both the numerator and denominator by the numerical value of the denominator. This is 8 hours here, so what we're doing is dividing by 8. 8 hours divided by 8 is 1 hour. 1,200 milliliters divided by 8 is 150 milliliters. So that's 150 milliliters over 1 hour, or 150 milliliters per hour. Now in practice, I wouldn't actually write it out and divide each one separate. I know the denominator is dividing out to 1. So all I would really do in practice is do the 1,200 divided by 8 to give me 150 milliliters in the 1 hour. So if I have 2,500 milliliters over 10 hours as my order, what is my milliliters per hour? Well, again, I make this a rate. 250 milliliters over 10 hours is 250 milliliters over 10 hours. As a unit rate, I know it's going to be 1 hour. What do I have to divide the 250 or 2,500 by? 10. 2,500 divided by 10 is 250. So 250 milliliters over 1 hour, or 250 milliliters per hour. A bit trickier. Let's say our order is for 450 milliliters over 30 minutes. We still want to know milliliters per hour. There's going to be a little bit more of a harsh conversion here. 450 milliliters over 30 minutes. We first have to convert our minutes into hours. So 1 hour is 60 minutes. The minutes were on bottom, that's why they had to go on top over here. Personally, I would cross cancel the 30 and 60, but you don't have to. So we have 450 times 60 in this case. What is that, 27,000, I believe? Milliliters. 30 times 1 hour is 30 hours. And it's just a matter of dividing out the 30. Comes 900 milliliters per hour. Now, of course, if you saw that 30 minutes was just half an hour, you can just double the 450. That is fine. Let's say that we are ordered to give 300 milliliters over 45 minutes. Let's find again milliliters per hour. So again, I would have to convert my minutes into hours, just like I did up here. So minutes are going to go on top because I want to get rid of minutes. Hours will be on bottom. 1 hour is 60 minutes. So my minutes cancel. I multiply that out. 300 milliliters times 60 is 18,000 milliliters. 45 times 1 hour is 45 hours. And now I have to divide out the 45. $18,000 divided by 45 is 400. So it's 400 milliliters per hour. What do you think? Not too bad. Before we wrap it up for the day, I'm going to show you one complex example of IV flow rates. So let's give you an order for, let's see here. $1,500 milliliters over 6 hours. So we're looking at the label on our medication, on our bag, and it is showing, and actually should scratch that, 1,500 milligrams over 6 hours. On our label, it shows 5 milligrams and 2 milliliters. And a drop factor of 12 drops per milliliter. What a drop factor is it's talking about the viscosity of the fluid. It's the thickness of the fluid. That's how many drops of that fluid it takes to make 1 milliliter of volume. So the lower that drop factor is, 10 or 12, I've seen them as low as 8, the thicker the medication is, the fluid is. For IV, I don't think I've ever seen it go below 8 because I don't think that would flow through the needle. I've seen it as high as, I know I've seen it as high as 20, it might be maybe even 25. So that's a pretty thin fluid, like a alcohol-based. So anyway, what we want now is we want drops per minute in our final answer. So our order, we're going to start out with the 1,500 milligrams over 6 hours. We're going to get rid of both milligrams and hours. Let's get rid of the hours first. Hours were on bottom, so we put them on top to get rid of them. So the hours cancel out. So right now we're in milligrams per minute. The minute can stay because we want minutes in our answer. So now it's the milligrams we've got to get rid of. So I'm putting milligrams on bottom. The only equivalency we have up here on our label that involves milligrams is 5 milligrams in 2 milliliters. So the milligrams are gone. Now the unit that we have on top is milliliters, and it's still over minutes. We don't want milliliters, we want drops in our numerator. So looking down here, we see the drop factor, 12 drops per milliliter. That is the same as saying 12 drops equals 1 milliliter. So over here I can put milliliters on bottom, drops on top, 12 drops in 1 milliliter. And that'll cancel out my milliliters. So now I have on top here 1,500 times 1 is still 1,500, times 2 is 3,000, times 12 drops is 36,000 drops. On bottom, 6 times 60 is 360, times 5 is 1,800 minutes. So 36,000 divided by 1,800 is 20 drops per minute. When you come back after spring break, that is going to be the first hour of our class dealing with, or a good portion of the first hour of our class at least, dealing with those IV flow rates. So for now, problems that deal with what we've been talking about, page 153 through 154, 1 through 15. That is the vocabulary from the page 150. Vocabulary will not be tested on the test, but it might appear, in a problem, so you need to know what that vocabulary means. You will be allowed to use your book, so it's not like you have to have it memorized. Page 162 through 163, 1 through 23. That's dealing with the dosage calculation formula and dosage calculations. Page 168 through 169 is going to be more on those fringes. And like I said, I will post those worksheets for you out there on Blackboard as well. I'll put them right next to the link for the recording so that they're in that section. And then also page 172, 173, 1 through 9, the odd. So with that, you guys have a great spring break. We'll see you in 2 weeks.
Thank you, you too.
Thanks.